aldehydes, ketones, and carboxylic acids. So let us review this lesson. Aldehydes, they are represented by RCHO. Ketones by, that is RCOR. Carboxylic acid is RCOOH. In fact, the carbonyl compounds are the most important compounds in organic chemistry because you have got the fantastic C double bond O group here. In the case of aldehyde, it is RCHO. In the case of ketone, on both sides of the carbonyl group, that is C double bond O group, you have R, alkyl group. And in the case of acid, on one side you have R, on the other side you have OH. So likewise, you can bring them in a common frame. Now, the aldehydes are called alkanals, AL, alkanals. You can call it ALKANAL, alkanals. And um ketones are called alkanones by IUPAC, alkanones. Then carboxylic acids are called alkanoic acid. So alkanoic acids. And we have got other derivatives of carboxylic acids also. For example, you have R C double bond O. Instead of OH, you can put halogen. They are called, that is, alkanoyl halide. When you put chlorine, alkanoyl chloride. For example, CH3 C double bond O Cl. What is that? Acetyl chloride or ethanoyl chloride. Acetyl chloride is a common name. CH3 C double bond O, then Cl means acetyl chloride. That is a trivial name, common name. And since it has got two carbon atoms, then you can call it ethanoyl chloride. Okay. So likewise, you can have many compounds. Then you have got ethanoyl chloride. What is a formyl chloride? HC double bond OCl. This is called formyl chloride because it is rooted from formic acid. And it means it is nothing but methanoyl chloride since it has got one carbon atom. When you count the carbon atom, you have to count the carbon atom of the function group also. Which is the function group here? C double bond O group is the main function. Okay. Right. And if it is amide, for example, instead of Cl, you can put NH2. What is that? Acid plus amine, that is amide. Okay. What do you call this compound? Formamide. Okay. Formamide. And what is the IUPAC name? Methanamide. So likewise, you can have methanamide, ethanamide, propanamide. You should be able to write the complete list at least for 5 to 6 members in each group. Then, and you've got some special compounds like vanillin, salicylaldehyde, cinnamaldehyde. So these are all the very important formula you must note down along with the structure. This vanillin is present in vanilla beans. You would have noticed this vanillin in ice creams also, vanilla ice cream. So that is the flavor. Salicylaldehyde, and actually that is it is rooted from obtained from the meadow sweet. Then cinnamaldehyde from cinnamon. So they are almost esters. They give very good flavors. The fruity odors are because of esters. And kindly go through the nomenclature of all these compounds, that is aldehydes, ketones, and carboxylic acid. And particularly this table is very important. For example, acrolein. This is nothing but CH2 double bond CH2 double bond CHO. This is nothing but acrylaldehyde, and it is also called acrolein. IUPAC wise 1, 2, 3. There are three carbon atoms, and based on that, you can call it prop. And the end is function group is anal, but there is a double bond, so enal. So prop to enal. Okay, so prop to enal. And when you got this CHO that is replaced by COOH means that is called acrylic acid. Nowadays, these acrylic acids are very, very popular in resin and paint industries. They are called acrylic resins. And you could have noticed these acrylic emulsion paints where you have got this acrylic acid because it is capable of forming polymers, and they are very good polymers. So likewise, you should be able to identify the structure and properly name it by common name as well as IUPAC name and develop the flashcard based on this. Then the structural aspect, I think I already discussed. You can watch my previous videos where I have talked about the formation of carbonyl group and what about this pi bond, pi back bond, sigma bond, all these things discussed in detail, and always go through these in-text questions. Okay, try to answer those questions clearly. Once you are able to attend the questions and write the answers clearly, you can understand the concepts very, very clearly. Then go through the preparation of aldehydes and ketones, and you can oxidize the alcohol to get the aldehyde or ketone because primary alcohol leads to aldehyde, secondary alcohol leads to ketones. And similarly, by dehydrogenation, then from hydrocarbons. And I think we already discussed these ozonolysis of alkenes in detail. Ozone. With the help of ozone, you are able to break the bond, and that is why it's called ozonolysis. So first it forms ozonides, followed by the hydrolysis. You are able to get the aldehydes, and you please watch our videos that have already been presented on ozonolysis separately. Then preparation of acid chloride, acyl chloride, from nitrile, from hydrocarbon, and especially I have discussed in detail about the Etard reaction. So kindly go through all these videos already done in our that is website or channel. Then preparation of ketones. Likewise, these ketones are actually that is you can take this Grignard reagent or MgX and combined with this cadmium chloride so that we are able to get this RCOCl. Okay, that is RCO. So these reactions are very, very important. So please go through that. And you have to, just like mathematics, you have to practice the reactions, write the reactions. Okay, then try to understand the mechanism behind this also. And then so the preparation part of it, and always once you finish a particular concept, for example, IUPOC, immediately go through the in-text questions and also search for the questions which are relevant to the preparation or IUPOC nomenclature in your book back exercise. Okay. For example, what is meant by all these things. So you can go through that. Okay. So name the following compounds. So this is IUPOC related. What I suggest is when you go through the books, just to find out the topic, for example, that is if you take any compound, any organic compound, these are the basic concepts. For example, if for any organic compound, you have the IUPOC nomenclature. So just get familiarized yourself with the various names, IUPOC. And immediately what you are supposed to do, that is solve the in-text questions. Otherwise, discuss. Then exercise also. So identify the particular concept-based questions and prepare like that. Don't prepare notes for everything. For example, that is you got IUPOC nomenclature, followed by that you got the preparation and then physical properties, sometimes a preparation along with the structure, then physical properties, then chemical properties, and application, the uses. Okay, in chemical properties, that is sometimes there will be more weightage to the named reactions particularly. And there are some mechanisms also. You can give weightage to mechanism and other general reactions. So likewise, you have to classify. So once you finished this concept, kindly go through the in-text question, exercise question. Then take up the preparation. This is the way you have to study your organic chemistry, not only organic chemistry, any topic. Go by concept. You have completed, for example, that is even in the case of electrostatics, you are talking about Faraday's, Coulomb's law. So immediately after finishing the Coulomb's law concept, what you are supposed to do? Solve the problems, write the questions based on Coulomb's law. This is the way you have to practice. Now, by attempting those problems and exercise, you get familiarized with your terms, definitions, formula, diagram. Okay, so never forget this method. And so I think we have completed these two. When I say we have completed, you are supposed to complete everything. And physical properties. So what is the trending? Okay. Then chemical properties. So chemical properties, probably there are some tricky aspects. If I tell you the mechanism, then it will be very easy. I'll discuss today that mechanism part of it so that it would be very interesting to that is go through other aspects about the chemical reactions and applications. You yourself can do it. After all, this is regarding the uses. So one thing you must understand, what are the things to be learned from me. That is very, very important. Okay. You may have some confusion in IUPOC. You can get it clarified. And you can write down the preparation. If there is any mechanism involved, you can talk to me. Let us discuss in the class. Then regarding the physical, there are some reasoning questions. You must understand the concept. If you are unable to answer the question, you can discuss in the classroom. Then regarding the chemical properties, as I already mentioned, if there is any doubt in the mechanism, you can very well talk to me so that I'll be able to explain the mechanism. So it may have a number of reactions. For example, I'll show you one simple mechanism where the condensation reaction is there, but you've got nearly about 7 to 8 reactions in that. Let me talk about this condensation reaction. So here, first of all, you've got here the nucleophilic addition reaction. And you've got almost 2 or 3 pages about this. Then based on that, and you've got a very important table, and you must by heart all these things. Okay. And based on that, you must be able to derive the particular reactions also, where you have got substantial questions based on this table. But you may not understand. Just by seeing this, don't attempt to by heart. Instead, by attempting the problems indirectly, all these contents will penetrate in your brain. Okay. So try to understand that and try to solve all the problems associated with that. Okay. Then, so in this reaction, chemical reaction, nucleophilic addition is a very important one that I will discuss. Okay. Please make a note of it. I will discuss this part. And then here, a reduction oxidation. So you know very well about that because I already explained about reduction and oxidation. Kindly go through that. Then regarding the alpha hydrogen, this is also fantastic mechanism. So I will explain about this. So this is the second part I want to give a stress in this. And then we have the other reactions like a formaldehyde, how these a formaldehyde can combine. Okay, so this is also called a Cannizzaro reaction. This is a very important reaction. So that I will explain. Then you've got electrophilic substitution reaction. I think you've got already some knowledge about. And then you've got, after all, some properties, uses, applications based on the aldehydes ketones, and you can do it. And the same thing is repeated here for carboxylic acid. Okay. So please go through the preparation part of it. Then you've got a lot of chemical reaction, and that too, this part is very important. and also you should have something about the reactions involving OH bond. So there are some interesting aspects here. I will I'm giving you some overview about this. For example, how they approach as far as the reaction is concerned. Now look at it. Chemical reaction. You've got R, C, double bond O, O, H. This is the carboxylic acid. Now how they approach, you just to note down. Reactions involving cleavage of bond. So what do you mean by chemical reaction? Cleavage of a chemical bond. Listen here. Cleavage of a chemical bond. So definitely, where are the chances of cleavage? And based on that, you will get the type of reactions. Correct? For example, if there is a chance of breaking of OH bond, you can say reaction involving OH bond. Do you understand this? But you have to write down like this. When you read this, you cannot simply read like reactions involving cleavage of OH bond. It is helpless. What you are supposed to do? About what we are discussing, carboxylic acid. What is the structure of carboxylic acid? The general format is this. And what they are talking about? Reactions involving cleavage of OH bond. So the split is going to take place here. So I have visualized, you can never forget. And then, so you know very well by splitting this, what happens? H will go, right? As H plus. It means it represents some acidic nature. And that's why we call it carboxylic acid. So in this case, we can definitely talk about the acidic nature of carboxylic acid, whether it is weak acid or strong acid. All these things can be determined based on this reaction mechanism. Because we know some knowledge about the inductive effect, inductomeric effect, all these things, mesomeric effect, resonance. So immediately you have to apply all these, that is a mechanism, that is these reaction effects, the substituting effects, all these things. For example, let me explain based on this one only. CH3COOH is there. CH3, CH2, Cl, COOH there. Okay, now in which case the acidic nature will be more, whether it is case 1 or case 2? Anyone? And why? Let me say, in this case, that is reaction 2 is more acidic than reaction 1. Do you know why? Because, see, what do you mean by acidic nature? Ease of removal of H plus. How easier the H plus can be removed. In the case of chloroacetic acid, because of the presence of chlorine, there will be a minus I effect, right? So it means inductive effect taking place towards the electronegative atom. And that is why the release of H plus will be much easier in the case of second. And that is why fluoroacetic acid is stronger than acetic acid. Now the question will be asked, which is more acidic? You have to write down the structure and apply these concepts. Then you can understand. Okay. And you cannot see for which what you are supposed to do. You have to encounter such type of questions, and if you encounter for the first time, it will take more time. But if you have already experienced this question, if you are already familiarized with this enemy, then you know how to tackle. And that is why I said that is always a practice the questions. Simply reading will not help to you. What you're supposed to do, you have to practice the exercise, practice the problem, and then only you can come out successfully, because you could have studied this is the question and this is the answer and why. That is the way you have to study. And if you are unable to understand, and probably in your reference books or guides or in your textbook or in your teacher notebooks, teacher classroom notes, they would have given some, and that is why I have seen many teachers that they used to give, they never allow the students to think anything. Instead, they give this question, answer, ready-made answer. But they don't allow the students to think. It's very easy for me to give the question. This is the answer. Question, this is the answer. But you will never have the practice, never have the experience of going through the textbook. Go through the textbook. Something like that is when you read the textbook, it's something like a comprehension. You try to understand the meaning given or meaning that can be taken in between the lines also. This is so if you do like this, you will have the habit of studying deeply. That is called studying. Otherwise, you are simply reading like question newspaper. So here, what you are supposed to do, it is see that is even in this title itself I have given you. Don't stop with reaction, involving cleavage, cleavage. What is this nonsense? Don't read. Immediately take the pencil and what does it indicate? Try to visualize it with your sketches. That's why it's called sketch notes. For example, say this is only a text, but I have made it as a graphics, and that's why it's called infographics. So the study itself is a design-oriented subject, and try to. In fact, I appreciate our Karunya to have a creative ideas to develop as notes, but it must be done for all subjects every time, not only for the competitive purpose. So reaction involving cleavage, I have clearly mentioned. And here also see, for example, don't stop with this. You have to build up like a structure. For example, SAR has already told H plus release is acidic nature. Okay, we will draw like this CH3, C double bond O and O, then H. Then how about a chlorastic acid? Let us put chlorine and CH2, then C double bond O, then O and H. So just by looking this, you will definitely understand that, oh, here there is a minus I effect because of the presence of electronegative atom. Finish. This is the way you are supposed to write down the notes also. Automatically, see, once you are able to understand, you can easily write down the answer. Even just in indicating this diagram is self-explanatory for it. And here, this is a releasing group. You know very well, methyl group is an electron releasing group, whereas a chlorine is an electron withdrawing group. So the electron abstract that takes place along the sigma bond, and that is here, it is minus I effect, here it is a plus I effect. You cannot say plus I effect, there is no effect. But even then, suppose if it is substituted by, instead of chlorine, there are three methyl group, then what happens? That will be much less acidic. Do you know why? Likewise, you should be able to build up. For example, I got an acid like this, CH3, 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 then C double bond O and OH. Now, shall we discuss on this part? For example, this alpha carbon atom, because you know very well this is a function group. Okay. So this function group and the carbon atom present very adjacent in the vicinity of function group is called alpha. This alpha carbon atom is surrounded or substituted by what? Three methyl group, all are bulky fellows. Okay, so these bulky fellows, they will try to expel the electrons. So this will push the electron. I don't want. This will push the electron. I don't want the electron. I don't want the electron. I don't want the electron. Then what about this oxygen? It will not take the electron from hydrogen. So it is already well satisfied with the release of electrons by this methyl group. Naturally, it will not have the tendency to kick out the hydrogen, take the electron of hydrogen. Whereas in this case, it will take the electron of hydrogen and that is why it becomes a H plus, right? Immediately you compare with the HCl, it will be much more. This chlorine, which is very aggressive in electronegativity, it takes immediately the electron of hydrogen and that is why there is an instant release of H plus in HCl. That's why we call it strong electrolyte, whereas acetic acid is weak electrolyte. And what about this? This is much weak. Okay, so when you study, you try to talk to yourself and make a logic and that is try to have a dialogue with that and verify with your answers also. Okay, right. So I think I was talking about the type of reaction, how to get the type of reaction. You must be able to remember like this. Okay, For example, whenever you take carboxylic acid, let us consider this carboxylic acid, that is CH3, or simply put R, C double bond O, double bond O, and O, then H. I said this is the first type. Okay. What is that? How to call it? Reactions based on the splitting of OH bond in carboxylic acid. Finished. Then what about this? So this is what they are given. See that? Reactions involving cleavage of OH bond. Okay. Now go to the second one. So they are talking immediately. They talk about the what dissociation constant, equilibrium constant, etc. pH, because it is something concerned with the release of hydrogen. If it is the release of hydrogen means definitely we'll discuss the nature of acid, pH of acid, all these things will appear. And definitely you can have one question like which is stronger, which is weaker, and you have to apply naturally the side effects like inductomeric effect, inductive effect, mesomeric effect, resonance, etc. And then here cleavage involving what? COH bond, another strike. So I can break here, I can break here. So this is second type. So what is that? This is the cleavage of CO bond. That's what they are given. What is that? CO bond means OH is already there. So COH bond. Okay, this is the second type. Okay, so when COH means what? Definitely, I will give some example like this. When you've got RCO OH. Now I want to react with, say, that is NH2OH or even HCl at the state, very simply. Okay. Now what happens? This C double bond O and here CO. Now OH bond will release, OH group will release as OH minus only. So in that case, what kind of electrolysis, lysis, homolysis or heterolysis? Heterolysis is an uneven cleavage. Why? Because this oxygen takes the electron of carbon also. And that is why here it becomes delta plus and this becomes delta minus. So this will transfer the electron towards it. And what about this? This HCl, it will break like this. And this fellow will have Cl minus, that is delta minus, and this is delta H. So these two will have an agreement to form H2O, right? H plus plus OH minus H2O. The remaining is Cl and that will add because this is plus carbonium ion. So the carbonium ion is an easy target for this chloride anion because carbonium plus. So what happens here? Or C double bond O, immediately you get. So you are able to get such type of compound RCOCl, that is called alkanoyl chloride, ethanoyl chloride, methanoyl chloride, propanoyl chloride, benzoyl chloride. What is benzoyl chloride? C6H5 COCl. So you are able to get such type of compounds. And what are all the compounds based on such type of splitting? You can have C6H5 CONH2 also, benzamide, methanamide, ethanamide. So amines also can react with this. Okay. So from this, it's clear that we are able to get the another strategy. What I have done here, that is the second strategy. What is the second strategy? Splitting of COH bond. What is the first strategy? Splitting of OH bond. Got it? Then you can go to the third one, third subdivision. This is 8.92 and 8.93. What is that? Reactions involving COOH group. So as a whole. So in this case, now let us have the third strategy. That is, it is going to break like this. CH3COOH. It means it involves the COOH as a whole. Okay. So that involves a COOH. Right. So this is the third splitting that involves a COH. I hope now you should be able to understand. Reaction involving COH group means what? The entire COH is going to take part means remove it and so that's splitting. And another one, substitution reactions in the hydrocarbon part. So which is the hydrocarbon part? This can be substituted. For example, I said acetic acid, alpha fluoroacetic acid. So this is hydrocarbon here. So proton by proton, it can be replaced. When one proton is replaced, it is called alpha fluoroacetic acid, dichloroacetic acid, trichloroacetic acid. Got this point? So based on the hydrocarbon substitution, you can get another reaction, and that is reaction fourth type. Okay. So now we have got 8.9.4, and then with that it's over. And if it is an aromatic compound, definitely it is a ring-based one. That's all. So the COH is entirely split like this. Now what you can do cleverly, try to map it. How to map it? Shall we map it? Go to the board image. I'll help you how to map. Please go through that. You can take this. I'll put it here. Put it at the center. Everyone can do. Do it small because we are going to include lot of reactions here. Now I will divide this group into four. The OH splitting can be done by that is Priya and Susmita. The second, what is that? You can start working on that. Start working on that. You have to do the mapping. Put like this. How you are supposed to do? Or C double bond OH. You take like this and target this one only. Okay. And based on that, you are supposed to write down the mapping like this. How many types of reaction? One, two, three, four. And if there is any subdivision, you can split like this. Can you do? Proceed. You can sit together and proceed. Then um, you can do it on the board itself. Both of you. Hello. Do it on the board. Then Corin, you can join with Emily to discuss on the splitting of what? COH bond, the second one. So you can write here, take like this and branch it. Okay. So I want to include everything here. And will be done by, the third will be done by this one as a COH. This break will be by Pranav and Gangesh. Okay. This is the third. And the fourth one is easy. One is alpha substitution, another is ring substitution. That's all. Okay. So go through. Come. You can use that book. No, no, no. Do it on the book so that I can correct it. First, we need to study on that. So we know. You have to. Please take the book and go to the book. Do what I say. I'll help you parallel. Now for Priya, what you can do, you take this COH group. So what you are supposed to do, others can also follow. For example, you are talking about acidity. Okay, so point number one, acidity. Right? Simply, that's all, acidity. That's all. You are going to talk about acidity only. Okay. And now, what are the points you can? Reaction with the metal and the alkali. So first reaction with metal. Okay, so this describes the acidic nature of this bond. Okay, so entire is acidity. So you can take like this. So this is something concerned with acidity. Put acidity. That's all, and put the box. Now what you can do? put various aspects. Acidity means reaction with the metal. Okay, so reaction with the metal. Then second, reaction with the alkali. Okay, so reaction with alkali. You must write everything. Okay, don't leave any reaction. Then, and here the mechanisms are also neatly done. First, go through the main contents. And here they talk about the pH value. So write down this pH value equation and the effect of substitution. As I was already, that is electron withdrawing group. So you can note down. So here you can talk about the pH and then effect of substituent. Okay. So based on this EWG and EDG. Okay. So you can split it and make it as a beautiful infographics. Okay. I hope I have given some ideas. And based on the ring-based compound also, you can put further. So this is based on aromatics. So for aromatics, what is that happening? So one, two, three, four, five. So almost five major subgrouping. And based on that, you can cite the example. So use that tool. And you can, Emily, what you can do is formation. This is point number one. So you can take as this reaction with COH bond. So you take like this or C double bond OH, right? Now we are going to split this one. Okay, so from here, what are the possible reactions? Okay, so what are the possible formation of anhydride? So this is formation of anhydride. Anhydride, don't say formation, simply put anhydride. Second, esterification. So ester. Okay, ester. And third, so likewise, you can build up the reaction. How many reactions? That's only four reactions. Okay, so we got four reactions. And write down the reactions also. Three. And what about uh, so now you write it on the paper and show it to me. Okay, if there is any doubt, you can ask me. Reactions involving COOH group. So what we are going to do, you put like this or COOH group itself. Okay, so put this one, even based on this. What are the reactions? That is a reduction. So reduction and then decarboxylation and then that's all, only two. Okay, so you can beautifully explain this. Okay, can you do that? Try. And you can include this one since yours is very small. You can include the substitution of carbon also. So here also. So here you can put the substitution. One is substitution of aliphatic, another is aromatic. Okay, so everything is finished. Now we have got almost divided the entire reaction into three group activities. So once you are able to do it nicely, make it as a concept map and convert it into a flashcard. And when you keep everything, it becomes the sketch note of what? Chemical reaction that is over. Carboxylic acid is finished. Okay, try.